So our problem was the skier is being pulled by a tow rope up a hill at constant speed. Draw a picture of the skier. Now draw a free body diagram of all the forces acting on the skier. Indicate the direction and magnitude of the forces with arrows. Discuss each force and how they compare to each other in magnitude and direction. So for this problem, it's better to just draw the free body diagram. So we have this hill, and it's going at some angle, theta, and it's easier to represent the skier simply as a particle, like so. And now we have to draw the forces acting on it. So the force of gravity, which we can indicate by F subscript g, the normal force, which acts perpendicular to the surface of the incline, and we'll just note that by F subscript n. And the problem doesn't state that this is a frictionless incline, so we're going to include the force of kinetic friction with F subscript k. And since the skier is going up a hill being pulled by a rope, we would have the applied force, which in this case is tension, since we have a spring. And now we can break up the force of gravity into its perpendicular and parallel components. So this would be Fg perpendicular, Fg parallel. And we can enlarge this triangle here, like so, and it would be a right triangle, hypotenuse. And then this angle theta over here is the same angle as the angle of the incline. So we'd have right here Fg parallel and Fg perpendicular, Fg parallel. And just through simple trig, SOHCAHTOA, we can denote the force of gravity acting perpendicular to the surface of the incline by F of g. We have right here adjacent over hypotenuse, so that would be F of g cosine theta, and the force of gravity in the parallel direction would be F of g sine theta. And this would be all the forces acting on the skier, which is being pulled up a rope. So we have the normal force acting perpendicular to the surface of the hill, the force of gravity acting straight down, and it can be split up into these components here, and the applied force, which in this case would be the tension, and the force of kinetic friction, since the problem doesn't state that this is a frictionless